I'm Marius van Niekerk, presently working at Voltron Data. This is Wolf. I don't know where Wolf is these days.
Quantstack.
Wolf is at Quantstack. He's got a shirt on, so I should have probably known that. And we're gonna cover a little bit about about what's been happening in Conda-forge recently. Who here has not used Conda-forge? Okay. So Conda-forge wouldn't be possible without a large group of people. You may see our faces everywhere on GitHub, and it's like so we've got a fairly active and large core team that keep everything humming. It's basically too many people to name, but it's a growing community, and we're friendly, so mostly friendly. And so the outline of this talk, we're going to cover a couple of these topics. So what is Conda? It's a cross-platform sort of package manager. It ships binary artifacts, unlike pip. And these days, Conda-forge supports a large number of sort of language runtimes. Predominantly, there's a lot of Python in it, obviously, due to its origins. But there's a large amount of C++, quite a lot of Go now, and sort of a very, very large R ecosystem. And then in a couple of other channels that aren't Conda-forge, there's a very large Perl ecosystem in the BioConda community, and several others. And so this is a little quick cheat sheet. If you've been using Conda without Conda-forge, there's a couple of equivalent behaviors. And so, in general, replace add a Conda-forge in most places. You may have heard in the keynote, somebody was having troubles with Conda not working. This is mostly due to Conda-forge's success, unfortunately. Conda-forge is really big, and so if you were to generally use Conda-forge without using Mamba or the new experimental Mamba solver built into Conda, it probably won't work for you in most cases. So as Conda-forge at the moment, we strongly recommend using Mamba to do basically everything with Conda, and then once the Mamba integration into Conda becomes mainlined in the near future, hopefully, then you should be able to just continue using Conda the way you used to. But at the moment, use Mamba for basically everything. You're going to have a far superior experience. And to that end, we also have we've got things like a mini Conda equivalent that Conda-forge packages called mamba-forge. That basically it ships a standard sort of mini Conda, but also with a lot of the Mamba binaries included, and similar for if you have Docker-based workflows. And so the Conda-forge user experience hasn't changed all that much from inception. And so generally, what you do is if you've got a new package, you create a recipe that sort of builds your package. You submit that thing to Stage Recipes. One of the extremely helpful Stage Recipes reviewers takes a look at it, says yay, this is good, or needs a couple of changes. There's a sort of lots of automatic builds happens on various of our CI providers, mostly on Azure Pipelines, thanks to the generous donation of extremely large amounts of CI time from them. Once that's through, you control and have commit rights to a new Git repo that we create that sort of houses this thing and keeps that thing up to date. And after that, you as the sort of feedstock maintainer control the release schedule of new versions of that package. Now we've got a couple of utilities, so you're not left to to the wolves of the darkness. And so we've got an admin bot that allows you to do a couple of sort of more administrative actions that due to that we sort of lock down some of the functions of those repos. And you may have seen the version tech bot in action. So whenever you push a new release of your package to PyPI, or if you're not using PyPI and you're managing something else, we've got a whole bunch of ways to find new releases. And that bot will kind of come in. These days, I believe the general sort of, due to the fact that the bot is quite busy, it may take, like 8 to 24 hours for it to find a thing at the moment. So just be patient. It'll make the pull request. But if you want to make one yourself manually, obviously go forward. Go ahead and do it. And then the bot will make a PR. It'll say it's like, hey, I bumped the version number. CI will run things, and hopefully everything's clean and you get a new package out. You hit the merge. There's another stage of activity that will then go validate and inspect the package after it's built to make sure that like things that shouldn't have been part of the package aren't there. So there's a couple of protections that sort of prevent you from clobbering things that are very important. So if you say try and clobber OpenSSL and things like that, you won't be able to, which is a good thing. And and then you may have also seen the large sort of automated migrations that Conda-forge runs. And so sort of we do a couple of these every year because it turns out there's a new Python release every year. And so stuff happens. And we don't necessarily want to impose the burden of like, hey, there's a new Python out. Go rebuild all your packages manually. We figure we can do this automatically for the most part. And so we provide a lot of sort of useful chat-based help, and you can ping most of the people on regular GitHub-based things. And so some vanity metrics. These are some numbers. They're pretty big. So we're nearing a 250,000 pull requests on the Conda-forge org as a whole. 150,000 of those pull requests were basically not made by a human, which is a lot. Quite a lot of these pull requests were also automatically merged by not a human, which is a different bot. Getting actual numbers on that is pretty hard because it turns out GitHub doesn't actually have a search that tells you which user merged the thing. And so you have to go build a large-scale scraper to go find out who actually merged this kind of amount of things. And so we haven't just done that yet. We're nearing in on a million total packages on Conda-forge. And we've exceeded the total number of downloads a month from the default Anaconda channel last year in about August. And it's like things have been going strong. And so you've seen this slide earlier, but it's like we do 300 million sort of downloads a month. The set of channels below it is for a couple of the smaller channels. So predominantly in the Conda ecosystem, there are really 3 big channels. So there's Conda-forge, Anaconda, which comes from Anaconda, and Bioconda, which does a lot of biostat stuff. And then the small lot at the bottom, they're still important channels, but they cover sort of smaller, very specific use cases. And so we do a couple of thousand builds a day, and as you see, there's a couple of these anomalous spikes that appear. Those are generally when some large migration runs. We haven't quite looked into what some of these other spikes were, but there are almost certainly some large-scale ecosystem migration. So when the bot picks up and it makes sort of a couple of hundred PRs an hour, stuff happens. It's pretty great. So size metrics. I'm always every time I plot this number of packages over time chart, I'm weirded out because graphs shouldn't look like that, right? It's like no realistic thing ever has a line that's straight. But apparently, this is what it's looked like every time I've plotted it, and I'm always freaked out by it. And so, this Conda-forge is made out of a large number of components. It's a distributed system run basically entirely on GitHub, treating GitHub as a database. And so GitHub is a database if you hit it really, really hard. Files are databases, right? So we can use a lot of things. So I'm not going to go over this whole thing. There's a lot of components here, but the general ones that users generally interact with is our various CI services and the sort of like the bots and the actions that are taken in there. Notably, one thing that is important here is when packages are published using Conda-forge, they aren't directly published to the Anaconda channel. They're published to a staging area first, validated, and only then moved over. So there's a couple of constraints that we've sort of that we have. Conda-forge doesn't actually have a permanent build infrastructure. So we have the capacity to build on quite a lot of things, but we are at the moment quite reliant on the goodwill of Microsoft to run a lot of our things at the scale that we need. There's a couple of other sort of CI providers that we used to use in the past, and some that we still use for a couple of sort of select cases. Notably, a couple of hard feedstocks that need to be built on PowerPC. Those are still built on Travis, but for the most part, basically everything gets built using Azure DevOps. We don't have any full-time engineers, though we do have some CCI grants that help fund some developments in the Conda and Conda EcoForge system. And we don't have any sort of persistent recurring revenue. We have gotten various donations over time from institutions, notably NVIDIA, that help to fund sort of some of our things where we want to do some work using systems that you actually need to pay for. And so we've got a couple of goals. Conda-forge is an extremely transparent organization. All the feedstocks are visible, all the recipes are visible, all the logs are visible, though they disappear over time because of constraints on the CI providers. Not much we can do about that. And on compatibility, we strive to say that things should generally be installable together, but practically speaking, there are limitations for how far that can go. Just because the channels are really big and things move at various different cadences. And so Conda-forge is made out of a bunch of automation junkies, I think, is kind of what we refer to ourselves at times. And so whenever possible, you should automate. Whilst the slide earlier, there were a lot of people involved in Conda-forge. The number of feedstocks in Conda-forge is several orders of magnitude larger than the number of people that do most of the general work in Conda-forge, and so we have to automate like everything, and to that same end is like ownership of these things has to be like extremely distributed. Sort of we view this as it's a large sort of somewhat commons resource, right? And so there's a couple of stewards, which are the core members, but ultimately, the feedstocks belong to the feedstock authors. And Wolf is going to talk about some fun new stuff.
Yeah. We've been quite busy to work on some additional things, and a lot of those have been enabled by the CCI grant that we received as Conda-forge. And so one thing we've done recently is we've set up an entire mirror of Conda-forge on a new GitHub organization that's called Channel Mirrors, and there's a full mirror of BioConda and Conda-forge as GitHub packages, because GitHub is actually running an OCI registry, and it turns out that you can push arbitrary stuff to an OCI registry, which usually is used for Docker images and things like that. And yeah, support is gonna come soon in Mamba itself to speak to that OCI registry. So, And with that support, we will also have the ability to have an entire list of mirrors that you can select and then distribute the load a bit. And yeah. Another thing that we've been working on at Quantstack is to add support for WebAssembly into the Mamba Conda ecosystem. And so we've added a new architecture, the mscripten32 architecture that can be used to create environments. And then you can use these environments and package them up. And so ultimately the goal is to put the WebAssembly support into Conda-forge and build some of the low-level sciencey tools, including Python and stuff like that, inside Conda-forge, using the same CI tooling, but for the mscripten32 target. And so we did some first experiments outside of Conda-forge because we didn't really know where to go with it in that mscripten-forge organization. And we have a blog post that just came out that shows what we did and how you can use it with Jupyter Lite. And one other thing that I'm quite excited about that we've been working on in the past quite a bit, but it's still not ready, is next generation of recipes. If you've written any recipes, you might have used the meta YAML files, and they do have a couple of words. So it's very hard to parse them with a computer because it's mixing YAML, it's mixing Jinja, and also there's comments that can be used as selectors for lines. And that's very hard to parse. So the idea is to take it one step further and go back to the drawing board and start again with a more easy to parse format. And so mainly that would be pure YAML and that makes it faster to parse. And also some other stuff. There's some recursion going on in the recurrent recipes, and getting rid of the recursion makes it faster. And yeah, just making it easier to reason about and debug, and then also take some inspiration for the YAML format from things like GitHub Actions or Ansible, or there's other stuff in other communities coming up like Melange and Alpine Linux. So most of that work is currently happening in the Mamba org organization in the Boa tooling. And it would be exciting if other people look into it, try it out, and give feedback. Other things that were enabled by the CZI grant that we're quite excited about is improved solver error messaging for Mamba. And when the support for libmamba lands in Conda, it will also immediately benefit from it. And then also a faster package management experience by only downloading new bits of repo data. It's something that we worked on, and extracting packages in parallel. And then one other thing is that we are investigating how to do package signing for Conda-forge, and need to make some more steps there, but that's something that's ongoing work. And the organization of Packaging Con, which already happened once last year, and it's going to happen next year again in spring. And if somebody is really interested in packaging, even if it's not related to Conda or Conda-forge at all, I would heavily encourage you to check it out and hopefully join. Do you want to take the last step?
I mean, yeah. And so, if you want to get involved in Conda-forge, it's like there's a couple of ways, right? So if you want to add some new stuff, then and you want to sort of be more involved, then you can reach out to the stage recipe reviews team. That review team is reasonably large, but they're quite busy. And so it would be great if that team expands a little bit, and we get some more people helping to review recipes and sort of get some of that stuff moving faster. There's a large amount of reviewers with various different sort of specializations of areas, and so we're always sort of interested in getting a couple of more reviewers in that space. We've got a couple of QA channels where it's people ask some questions like, hey, it's how do I do X? And generally most of that happens on Gitter. Sort of practically speaking, because Conda-forge is so heavily distributed, if you make issues on a random feedstock, odds are people don't see it, just because it's really big. And so there's a couple of repos that do have more active eyes on it. And so sort of general Conda-forge sort of questions and issues are best done on there's a repo which is the Conda-forge org repo. There's a link in the sort of top of the page, and these are all clickable links. So and then if you want to get even more stuck into it, or you're automation obsessed, there's a fairly active bot team that sort of keeps the engine of Conda-forge running, and so that has a lot of sort of general long-term interesting things. The bot code is some relatively interesting stuff. It turns out Network X is pretty great for packaging, so and even for more things than just like graph traversal. There's some importance calculation done there, and interesting stuff. And then, of course, if you want to sort of financially support it, we're a NumFocus affiliated, a NumFocus fiscally sponsored project, and so we take donations, and then we use them for useful things, like working with CI providers as well as sort of clouds for compute capability. Thanks.